or the ammonium polyacrylate and other things listed over here. These are the binders and these are the plasticizers. And the solvent-based systems are most widely used because industrially, it gets dried up very fast, so that your production capacity will be higher. That's why mostly the solvent-based tape casting process is mostly used. Here the solvents are acetone, ethyl alcohol and so on, and dispersant is fish oil and corn oil and so on. Binders is polyvinyl butyrol, plasticizers, benzyl butyl phthalate and so on. So this is the chemistry part of the tape casting slurry. Coming to the applications, they find lot of applications: multi-layered ceramic packages, molten carbonate fuel cells, and even solid oxide fuel cells, substrates for electronic circuits, piezoelectric sensors, actuators, microphones, oxygen and NOx sensors and so on, and multi-layered ceramic capacitors. In today's talk, I will mainly focus on substrates for electronic circuits, basically aluminum nitride and the alumina, and then the solid oxide fuel cells and oxygen and NOx sensors. So if you look at the worldwide players who are playing a key role in the ceramic substrate market, you can see Asian continents and other continents. And when we started this work, there was no Indian company which was manufacturing the ceramic substrates. So maybe for those who don't know what are ceramic substrates, they are similar to the PCB, so you can replace PCBs with the alumina substrates, and they play a very important role in miniaturization of the electrical hybrid circuits. There is a huge potential for this. The market survey shows that it is going to grow at a very high rate, and globally there is going to be a surge in demand, mainly because of the mandated regulations, particularly the automobile companies, where the automobile regulations where we have to use oxygen and NOx sensors, and with the upcoming EV market, these ceramic substrates are going to play a huge role. And why ceramics for space electronics? Apart from the other properties, they can form hermetically, packages can be easily formed, and they can cope with harsh environmental conditions. That's why they are preferred substrates for space electronics. And coming to these are all the basic requirements for the ceramic materials for using them in electronic packaging applications. And this is a multi-chip module technology where we are using ceramic substrates, thereby we are able to miniaturize this. And there are different types of multi-chip module technologies. Particularly our focus is on HTCC, wherein and there is something called as LTCC. I think Dr. Ratish already showed some slides about that. So our focus is on HTCC, which I will be showing in the later thing. This is a comparison of the PCB, the LTCC, the HTCC and silicon, and so we can see that the emissivity is very good with LTCC and HTCC, and the water absorption is 0% in this, and apart from other advantages like the thermal conductivity and all those things. And coming to ceramic substrates, again we have 96% and 99.6% alumina and aluminium nitride. These are the most widely used ceramic substrates. So when we were working in our laboratory on the solid oxide fuel cell work, we were doing one project with QME, and Dr. Shamrao is here. So his team visited our lab and they saw the YSD substrate what we were making. So Dr. Sham and his team, they wanted to know whether we can make alumina substrates. At the first instance we said yes, because when we were working in the lab, the students had filled alumina powder in a zirconia bottle, and we had ended up making alumina tapes, and we had optimized everything. So it became very easy for us, and we could optimize all the conditions, like they wanted like 100 micron freestanding film, we could make it 250 micron, 625. So both alumina and zirconia, we have done this work within 1 year, and we have transferred this technology to QME. And also I would like to say here that we did not have a tape caster to do our work, so we have just invested 1.5 lakhs and we have made our own tape caster, and with that we could do a technology transfer. And we can see some of the properties of the indigenous substrates with the benchmark, I think, Hoostech sample. We can see that the edge finish is very good with our CSR NAL samples, and we could get samples without burrs and pits and with a surface roughness of less than 40 nanometers. And our work did not stop there, and we have helped them in setting up the facility and also training them at their center. And you know, when you go from lab to fab, we have to really optimize so many conditions. You know, what you do in the lab, it will not work in the industry. So my colleague Senthil has really worked hard, and he has done that successfully. And now I think QE is making these substrates, and you can see that these substrates are now available in the market. So this is one example of Make in India. So we start with the powder, we mill it, we tape cast, then we get the tape, then you blank it or cut into the desired shape, and then you stack it. So the whole process is shown here. So we follow the same shape. So you punch it, the required wires and all those things, and then you do the printing. We use a textile printer, and we have modified and used for printing. And then these are all stacked. In case of LTCC, a low temperature is used for firing. In case of high temperature co-fired ceramics, we use a high temperature like 1350, 1450, and so on. So it is finally co-fired, and then you get the final product. So particularly VSSC wanted a different composition of alumina, that they name it as compensated alumina, because they found that alumina which is used industrially, they suffer from dielectric constant increase with temperature. So they have made a different composition of alumina, and with the properties shown over here. So we have successfully made these tapes, and we have provided them, and they are used in their SAT facility, and they have made the circuits. In the beginning it was not easy, so we had to optimize our tape composition and so on, because the lines were not printing properly, the tungsten paste and all was not adhering, so on. So we optimized all this process. Even sintering, you can see that our indigenous sample is to sinter very fast, and a lot of warpage issues. Finally we solved all this problem, and we have really done this work. And then we also did aluminium nitrate. So aluminium nitrate is going to be the futuristic ceramic substrate material, because beryllium oxide is very poisonous, and it has properties equivalent to beryllium oxide. So we can replace the beryllium oxide with aluminium nitrate. So we have also made aluminium nitrate tapes, and we have shown that it's possible. So now we are really poised to take up any activity related to aluminium nitrate substrates for any application. So we also had an opportunity to work with Debel to develop an oxygen sensor for pilot life support system, which is a alberometric oxygen sensor. And then recently we had an opportunity to develop oxygen and NOx sensor. Again, this is an high temperature co-fired ceramic technology. So we have developed this technology. I think there's a video I can just show you. Can somebody help me? So you can see this is the way we have fabricated our oxygen sensor. It is a 830 micron thick sensing element. So I'll just take 2 minutes. So it has like an exhaust, the sensor basically is made of zirconia, and it is based on the Nernst potential. So we have a reference electrode, which is, we have to have a hole or the cavity from where the oxygen is sucked from the air, and from the exhaust another hole is there. So all these things have been made, and this sensor will work only at high temperature, because zirconia is there and even the exhaust is at high temperature. So we have made a heater which that heater will heat up very fast within 10 seconds, so that you get very high temperature. And apart from that, this is finally the sensing element, and apart from that, all these components have been all indigenously developed. we had really very good cooperation from the industry. They have worked hard with us, and we have made everything in the country, and the oxygen sensor is here. We have a joint patent file, and you can see the performance comparison with the commercial sensor. This is what the previous chairman was asking us. You have to benchmark your samples. So we have benchmarked the thing, and you can see here also we have done the peak output voltage. All those benchmarking we have done. We are very close to the commercial sensor. And these are the specifications, and NOx sensor also we have similarly fabricated, and now we are in the process of developing the circuit for that. And all this was possible because of our, we had a laser micro machine where we can machine both green samples and also the sintered ceramic substrates. So apart from this, we have worked on the SOFC, where again we have used the tape casting aluminum nitrate based HTCC packaging system, and we have done oxygen and NOx sensors suitable for automobile application. I think within another 1 year you will see these products in the market. And finally, I can say that tape casting is a really very versatile technique. So the imagination of design engineers in the future will undoubtedly lead to new and exciting applications for this technology. So I would like to end saying that so industries have to work closely with research institutes, and also it is time for us to innovate in India. Thank you all for your patient hearing.